All right, let's talk about this. This aluminum can, right? It feels so simple, so disposable, you probably don't think twice about it. But what if I told you its story is, well, it's epic? It's a journey that started billions of years ago deep inside our planet. Seriously. So let's get into it.
So here's the game plan for this explainer. We're going to follow the entire life story. First, how these metals even came to be. Then, the crazy process of getting them out of solid rock. After that, we'll see how they're shaped into, well, everything. And finally, we'll look at what happens next, how their story never really ends.
You see, it's not just cans. Everything, your phone, the car you drive, the buildings we live in, they all have this secret history. And I promise you, once you hear it, you'll never look at a simple piece of metal the same way again. All right, section 1. So our story doesn't kick off in a factory. Not even in a mine. Nope, we have to go way, way back. We're talking geological time to see how the Earth itself literally cooks up these treasures. Okay, so check this out. The key thing to understand is that valuable metals aren't just everywhere. They're not spread out evenly like butter on toast. They're concentrated by these huge, powerful geological events over millions, even billions of years. Think about it. Billions of years ago, ancient oceans were creating massive bands of iron. Then, much later, you've got volcanic vents deep in the sea creating the right conditions for copper. And for aluminum, that comes from thousands of years of intense rain and weathering, basically washing away everything else and leaving the good stuff behind. And all that concentrating action creates what we call ore. It's a super important idea, but it's really simple. Ore is basically just a rock that's got enough metal packed into it to make it worth all the trouble. And believe me, it's a lot of trouble to dig it up and get that metal out. Okay, so we found the ore, now what? Well, this is where the human part of the story really kicks in. It's this incredible mix of brute force and really clever science, all for one goal, freeing that tiny bit of valuable metal from a whole lot of rock. First things first, you gotta get the rock out of the ground. And how we do that really depends on how deep the treasure is buried. If it's close to the surface, we dig these enormous open-pit mines, just gigantic holes in the ground. But if the ore is deep, deep down, then we have to go underground, carving out these complex tunnels and shafts to get to it. But just getting the rock out, that's only step 1. The real transformation, the real magic, happens next. You can think of it in 3 big steps. First, crush it all down to a fine powder. Second, concentrate the good stuff. And third, the grand finale, smelt it with incredible heat to finally get that pure metal. And that concentration step, it's fascinating. It's not a one-size-fits-all deal. Different metals need different clever tricks. For iron, it's pretty straightforward. You can just use giant magnets to pull the iron particles out. For aluminum, use a special chemical process. But my favorite is for copper. It's called froth flotation. It's wild. It's basically like attaching tiny little life vests to the copper particles, making them float up in a bubbly froth so you can just skim them right off the top. So cool. And that leads us to the fiery climax of this whole extraction saga, smelting. This is where you use extreme, almost unimaginable heat. Inside these massive furnaces, you're finally breaking the chemical bonds that have held that metal hostage inside the rock for, millions or even billions of years. It's a pretty dramatic moment. And when we say extreme, we mean an extreme amount of energy. It is just staggering. Take aluminum, for example. It's not just heat, it's a massive jolt of electricity, a process called electrolysis. To make just 1 ton of the stuff takes about 15,000 kilowatt hours. That's a huge amount of power, which, by the way, is exactly why you almost always find aluminum smelters built right next to something that can generate enormous amounts of electricity, like a giant hydroelectric dam. Okay, so after all that, we've got it. Pure metal, usually in these big, heavy bars called ingots. So now what? Well, welcome to part 3 of our story. This is where that raw, basic material gets turned into all the amazing things that shape our modern world. You can almost think of it like each metal has its own superpower, its own special mission. Steel, its job is to be strong. It's the literal backbone of our skyscrapers and our cars. Aluminum is the lightweight champion, strong but not heavy, which is perfect for airplanes and, our soda cans. And copper, it's the master of electricity, the thing that lets power flow through all our electronics and our homes. And we have so many ingenious ways to get these metals into the shapes we need. We can melt them down and pour them into molds. That's casting. We can hammer and press them into shape with incredible force. That's forging. We can squeeze them through rollers to make thin sheets, or even pull them through tiny little holes to create the hair-thin copper wires that make our digital world possible. But the story doesn't end there, does it? I mean, what happens when that car hits old or that building comes down? This is where we get to the final and maybe the most important part of a metal's life story. So is that it? Does it all just end up in a landfill? For so many materials, yeah, that's the end of the line. But for metals, no way. This is where their story gets really interesting. It's not the end. It's just the beginning of the next chapter. Get ready for this, because these numbers are just wild. Recycling an aluminum can saves 95% of the energy it takes to make a new one from scratch. Let me say that again, 95%. And for steel, it's around 74%. This isn't just some feel-good environmental thing. It's unbelievably efficient. We've already done all the hard work of getting it out of the ground. And the process itself is pretty slick. It's kind of like a simplified version of making it the first time. All the scrap metal gets collected and sorted, often with huge magnets that just pluck the steel and iron right out. Then it gets shredded up, cleaned, and melted down in a furnace, ready to be made into something totally new. And this, right here, is the real superpower of metal. Think about paper or plastic. Every time you recycle them, they get a little weaker, a little worse. Not metal. You can melt it down and remake it again and again and again, pretty much forever. And it never loses those core properties that made it so useful in the first place. It's basically immortal. This incredible quality, this immortality, makes metals the absolute poster child for an idea called the circular economy. And the concept is simple. Instead of our usual straight line where we take, make, and then throw away, we start thinking in a circle. We design things from day one with the end in mind, making sure those valuable materials can be easily recovered and used again, forever. So really, what this all comes down to is a change in how we think. After seeing this incredible journey, right, from a rock that formed billions of years ago to this useful thing in our hands, it's clear we can't just treat these materials as disposable. They're valuable resources that we need to be smart about. So next time you grab your keys or open a can, just take a second. Remember its incredible, extraordinary story. These materials literally built the world we live in. So the big question we have to ask ourselves now is, how are we going to build their future?